Let's move to drawing number 7. In drawing number 7 as well, you have 3 problems, and all the 3 problems are based on simple position 2. So let me explain you what is simple position 2, then I will take up the first problem in drawing number 7. So like in the simple position 1, here also we will have those 4 questions, and let us answer them for you to understand what is simple position 2. The first question is, what is simple position 2? A lamina resting with its surface on HP, just like in SP1, the entire surface should be on HP, with one of its corners on the right side. Okay. If it is a, let us say, a pentagonal lamina, this is a pentagonal lamina, pentagon. In SP1, what did I do? How did I select the SP1? The surface should be on HP. This is common for SP1 as well as SP2. But in SP1, I took the right side edge perpendicular to VP. So this was the position. But here, I must take a corner on the right side instead of taking an edge. So it is exactly opposite. I must take the pentagon in this position so that this corner comes on the right side. I think you got it. Okay. So when you go to next step, you will make the surface inclined to HP, and only the corner will be resting on HP. This is how you make the surface inclined to HP, so that the lamina is resting just with a corner on HP. Okay. So instead of an edge, you are keeping a corner on HP. That's all the difference between the simple position 1 and simple position 2. Okay. So it's important that you draw the pentagon taking a corner on the right side. So if it is a triangle, let us say the lamina is a triangle, you will have to start by taking a corner on the right side like this corner. If it is a square, even then you will keep a corner on the right side. Like this you should keep. This corner should come on the right side. So whenever I say simple position 2, what should come to your mind is, it should be resting with a corner on HP. So we take it on the right side. So that's all the difference between SP1 and SP2. Instead of an edge, you are taking a corner on the right side. So that is simple position 2. A lamina resting with its surface on HP with one of its corners on the right side. Now when to adopt? Just like in SP1, here also there are 2 conditions. What are they? A lamina should be resting with one of its corners on HP. That is one condition that should be given in the problem. And then surface is inclined to HP at an angle theta. Just now I have shown. Okay. So when that is the condition given in the problem, you can safely adopt SP2. When you see those 2 conditions, what are the conditions? One corner of the lamina should be on HP. Then the second condition is the surface should be inclined to HP. So when you find those 2 conditions in the problem, you can safely adopt SP2. So when you have decided that you have to adopt SP2, how do you start the problem? You will start by drawing the top view first with a corner on the right side. In SP1, what do? There also you start by drawing the top view first, but you take an edge on the right side and you take that edge perpendicular to XY. Okay. Here you just take a corner on the right side. So if it is a triangle, I will draw my top view like this. This corner is coming on the right. If it is a square, I draw the square like this. I draw the edges inclined at 45 degrees. If it is a pentagon, you draw the pentagon like this. If it is a hexagon, it should be drawn like this. This corner, in all the cases, that corner is important. Okay. Then how to proceed? SP2 first, HPC and then VPC. Same. Whenever you are starting a problem by drawing the top view first, it is the HP condition that you will satisfy first. Then only you go to VP condition. In some problems, just to confuse you, he may give the VP condition first. When you read out the problem, VP condition may be given first, HP condition may be given later in order. But when you are solving the problem and when you are adopting SP2, it should be HPC that should be satisfied first. You should know this. Okay. So with this introduction, having gained this knowledge, you can adopt any problem on SP2 now. There are 3 problems to be solved. I will take up the next problem now. Okay, having understood what is SP2, simple position 2, we can take up the problems now on drawing number 7. This is the first problem on drawing number 7. Its reference number is 2.3.4. The reference number from VTU question bank is 9 and D7, drawing number 7. The problem goes like this: a square plate, that means a square lamina of 40 mm sides, rests on HP. How is it resting? Is it resting with edge on HP or corner on HP is not given. You just mentioned that it is resting on HP. So you are still not sure whether it is SP1 or SP2 till here. Just it is mentioned that it is resting on HP such that one of its diagonals is inclined at 30 degrees to HP. You are still not sure whether it is resting on an edge or a corner. What is given? It is resting on HP in such a way that one of its diagonals is inclined at 30 degrees to HP. This is a square lamina. Okay. What is given? One of its diagonals is inclined at 30 degrees to HP. So suppose if I take the edge on HP and make the surface inclined to HP at some angle, will the diagonal be inclined to HP? It will be the surface inclined to HP, not the diagonal. Only when you take the corner on HP and make the surface inclined to HP, this diagonal also will make the same angle as the surface. Okay. So this is what you have to understand in this problem. When it is given that the lamina is resting in such a way that the diagonal is inclined to HP at some angle, indirect way of stating it is resting with a corner on HP and the surface is inclined to HP. That is one way of giving it. The second way of giving it is just the diagonal is inclined to HP at 30 degrees. Okay. So you should understand that you have to start with this position. In other words, this is simple position 2, taking a corner on the right side. When you go to next step, you take this corner on HP, rotate the surface, make the surface inclined to HP so that the surface is inclined to HP and the diagonal is also inclined to HP at the same angle. Both the surface and the diagonal will make the same angle, 30 degrees to HP. That will be your second step. So both the conditions that are required for you to adopt SP2 are there. What are they? Corner on HP and surface inclined to HP. Of course, it is given indirectly. Indirectly saying that this diagonal is inclined at 30 degrees to HP. Okay, then what is HPC and what is VPC? HPC is the same thing. Diagonal is inclined to HP at 30 degrees is the HPC. And what is VPC? The diagonal is inclined at 45 degrees to VP is VPC. The same diagonal which is making an angle of 30 degrees with HP should make an angle of 45 degrees with VP. This is VPC. Okay. Okay, so you have concluded that you have to adopt SP2. So I'll start by drawing the top view first and take a corner on the right side. Okay. So it's a square of 30 mm edges. So when you do it on your sketchbook, what do? Start with a point here, draw two edges With your protractor you can mark 45 degrees on either side, okay, and mark 40 mm on each of them. So I'm drawing the square. So I'll start with this corner now. This is the corner which I am going to keep on HP. A, B, C, D. So here, if you have not identified the problem properly, whether to follow SP1 or SP2, by mistake, if you have started by taking a edge here, the problem is gone. The entire problem is gone. Okay? Instead of a corner, if you take an edge here and start the problem is gone entirely. You'll get 0. Okay? So you are positioning it in such a way that you get a diagonal AC here parallel to XY line. Let me dimension this. This is the edge is given as 40. Project it so that the front view is a line. C dash, B dash, D dash in brackets and A dash. This is the lamina. Here A is a corner, B is a corner, D is a corner, C is a corner. You don't have any edges here. There are no edges. Okay? AB is an edge, BC is an edge, CD is another edge, DA is another edge. Okay? Done. So this is SP2. After this I will satisfy HPC. What is HPC? The diagonal AC is inclined at 30 degrees to HP. Okay? That's the reason why AC is taken parallel to XY line here. In other words, I have taken a corner on the right side. So rotate it in this direction and draw this line inclined at 30 degrees to XY with A dash on XY. Same length, whatever this, I don't know what is its length. It's nothing but the, if this is A, this will be A root 2, okay, if you numerically calculate. But if you take, you can take this with the help of a compass. Draw it inclined at 30 degrees. And then you can mark the points C dash and B dash D dash. B dash D dash will be midpoint. From here, just you can transfer the distances. Okay, this distance here. So I have made the diagonal inclined at 30 degrees to HP. Let me project it and get the top view. A, B, C and D. This is no more a square now. All the edges are apparent in length. There is no true length at all. Okay? None of the edges are in true length. All of them are apparent in length. So this is how you satisfied HPC. Yes. Now comes the very important step in this problem, VPC. Okay. What is VPC? The same diagonal AC is inclined at 45 degrees to VP. I once again repeat it. The VPC is the diagonal AC is inclined at 45 degrees to VP. When I say diagonal AC, it means that the true length of the diagonal AC. That's the meaning. Okay? The true length of the diagonal AC is inclined at 45 degrees to VP. Let me check whether AC is in its true length here. Is AC in its true length? This is the true length of AC. But this one, this is not its true length, it is its apparent length, because you made AC inclined here. When you project it, it's no more true length. It's no more true length. Okay. If you remember, you have the true length principle in straight lines. If the top view of a line is parallel to XY line, its front view is true. So A dash C dash is true length. AC is not true. AC is apparent length. Okay. But what is the VP condition? The true length is inclined at 45 degrees to VP. The true length of AC is inclined at 45 degrees to VP. But I don't have the true length here. I have apparent length. So this is a condition where you have to find the apparent angle beta. Phi is the true angle and beta is the apparent angle. If you remember, we have used it in straight lines. Okay. So if 45 degrees corresponds to true length, what is the angle corresponding to apparent length is what you have to find. Okay. How to do that? How to find the apparent angle? Let me show to you. First I will start by taking this angle 45. Let us draw a line inclined at 45 degrees to XY. Because this is true angle, in this case I can say phi is 45. Phi is nothing but true length. So what is beta is what I have to find. Okay. Because this is true angle, I will take the true length of AC on that. What is the true length of AC? This much. You can take this with compass. Okay. So I will take A here. Because it is true length, I will call it as AC1, just like in your straight lines. Okay. So this is a true angle. I have marked a true length of AC on that. Okay. Now how to get beta? I will draw the locus of C. We are going back to straight lines once again. I have drawn the locus of C. Now I take the apparent length of AC as radius. Measure this with compass. This will be less than this. Okay. Measure this with compass. Take A as center and AC as radius. Cut this. So this is the top view of AC. In other words, this is the apparent length. Okay. So if you just extend this line, you can show the angle beta. This will be beta. And beta should be 55 degrees. You should get beta as 55 degrees. It's very important how to find beta. Okay. What did you do? You started by drawing an angle of 45 degrees, which is true angle, and then you mark the true length of AC on that. True length you get from the first step. Measure this with compass, mark it here, anywhere you can mark on that line, and I called it as AC1 because it is true length. The end is called by some prefix. Then I have drawn the locus of C, draw a line parallel to XY. Then go to second step and measure the apparent length of AC with compass. Take A as center and this length as radius. Cut the locus of C, you will get the apparent length. And then you can measure its angle beta. It should come to 55. Now this AC is here. Okay. So you should construct this rhombus here with this as AC. Understood? It's quite easy. What you can do is, this is nothing but the perpendicular bisector of AC. Okay. So for AC, you can draw a perpendicular bisector passing to its midpoint. This is perpendicular to AC, passing through its midpoint. Then measure these two distances, center to D and center to B, mark them. Center to B is this, center to D. This is one of the methods. No, I don't want to draw this perpendicular bisector. I want to use arcs. You can use arcs also. A to B. A to B, draw an arc. C to B, draw another arc. By drawing two arcs, you can get B. Similarly, this side also. Draw two arcs and get D. In either of the procedures, okay? Whichever you feel convenient. Either drawing perpendicular bisector or drawing arcs, you can get the points B and D. Just connect them. Okay. Then project and get the front view. First let us get A. This is the locus of A, so A dash is there. Draw the locus for B and D. Project the points B and D. This is B dash. This is D dash. Draw the locus of C. Draw the projector of C. Just connect A, B, C, D by straight lines. A dash, B dash, B dash, C dash, C dash, D dash, D dash, E dash. That's how the front view appears in the last step. Okay. So, what did you satisfy? VPC. So, you should know what is the condition for you to adopt or to find beta. When should you find beta? Okay. When should you find beta? When an edge is in its apparent length, when an edge is in its apparent length, and when its true angle is given. And when its true angle is given, you need to find the apparent angle beta. Please make a note of it. Okay. I can also write here when to find beta. When an edge is in its apparent length and when its true angle is given, beta has to be found. The apparent angle beta has to be found. Make a note of this. Why we didn't do this in the last two problems? So far we have not found beta because you are given the true angle even there, but the edge also was in its true length. In the second step, that particular edge for which the angle is given with VP, it was in its true length. So I didn't have to find beta. If you have a combination of true length and true angle, there is no requirement of finding beta. The requirement of finding beta arises only when the length is apparent and the angle is true. Okay. So if you look at the previous problems, you can read the VP statement, the VP condition. Whatever angle is given, it is given with reference to an edge which is in its true length. So I don't have to find beta in those cases. But in this case, I have to find the apparent angle beta because the edge is in its apparent length, whereas the given angle is true angle. Suppose in this problem, you are given the angle as apparent angle, then straight away I would have rotated this. I don't have to find beta even in that case. If you are given apparent angle when the edge is in its apparent length, even then you don't have to find beta. Straight away I will rotate to whatever angle is given and solve the problem. But how do you identify whether the given angle is true angle or apparent angle? That is another question. This is true angle. Straight away if it is given the diagonal is inclined at 45 degrees to VP, that is true angle. Then what should be the statement for beta or apparent angle? It can be given like this. The top view of the diagonal is inclined to VP at 45 degrees. That is apparent angle. When I use the word top view of, then that is the apparent angle. Instead, it can also be given like this. The edge appears to be inclined at 45 degrees to VP. Even then it is an apparent angle. So when I use the term top view of, or when I use the term appears to be inclined, those are apparent angles. Okay? Otherwise it is a true angle. So when you are satisfying VP condition, it's very important to identify whether the given angle is true angle or apparent angle, and whether that particular edge is in its true length or apparent angle. It's very important to identify. Okay. So this is a very important point which you should make note of, this one. When you have this combination, you have to find beta. So that is about the first problem. Let us take up the next problem.